In this video, we are going to solve some problems based on conservation of mechanical energy. So here we have got, starting from rest, a 75 kg skier. So starting from rest means Vi is equal to 0. The mass is given to us as 75 kg. So the skier is sliding down a frictionless slope that is 15 meter above the ground. So we have got the height as 15 meter. Question is asking us what is the mechanical energy of the skier at position A. Mechanical energy is given by this formula, ME is equal to KE plus VE. Because he is starting from rest, so kinetic energy will be equal to 0. So we can cancel that out. That means ME will be equal to PE, which is gravitational potential energy, which is mgh. Now we can substitute the numbers for mg and h, and we get the answer for mechanical energy, which is 11,025 joules. Next, it's asking us find the skier speed at position B. So we know that conservation of mechanical energy says that mechanical energy remains constant. So mechanical energy at point A will be equal to mechanical energy at point B. So we can write 11,025 is equal to mechanical energy at B, which is kinetic energy plus GPE. So what we did here is we substituted the mechanical energy for A, we substituted this number here. Okay, here 11,025, and then mechanical energy at B, we are writing it as KE plus GPE, which is the formula for mechanical energy. Now point B is at the ground, that means the height is equal to 0. So GPE will be equal to 0. So we can cancel out GPE. So we get kinetic energy at B is equal to 11,025, which we can replace with the formula for kinetic energy, half mvb square equal 11,025. The mass is given as 75. Then you can use your calculator to solve for VB, which is 17.1 meter per second. Next, we have a problem on simple pendulum. The bob of the pendulum shown below has a mass of 2 kg. The motion started from position A at a height of 30 centimeter. So the mass is given as 2 kg. The height is given as 30 centimeter, which we have to convert into meter. So 0.3 meter. The string is massless and the frictional forces and air resistance are negligible. So the first part is asking us find the mechanical energy of the bob at point A. So at point A, to find the mechanical energy, we'll write the formula KE plus PE. Because at point A, the bob was at rest, so kinetic energy will cancel out and mechanical energy will be equal to potential energy. And that potential energy will be gravitational potential energy, which we can write with the formula mgh. We have got what's the mass, what's the g, and what's the height. We can multiply it. We get the answer as 5.88 joules. Next is asking find the speed of the bob at position A, which is at ground level. So again, we'll use conservation of mechanical energy. Mechanical energy at A is equal to mechanical energy at B. Mechanical energy at A we found already, which is 5.88. Mechanical energy at B we can write as kinetic plus gravitational potential energy. Now we'll focus at point B. Point B, the height is equal to 0. That means GPE can be cancelled out. So we'll get kinetic energy is equal to 5.88. And then it's asking us to find the speed. So we'll replace the formula for kinetic energy with half mv square. And the mass is known to us, which is 2 kg. And we can solve it for velocity, which is 2.42 meter per second. Next is asking mechanical energy at point C or position C. Again, using conservation of mechanical energy, we know that at all the points A, B and C, it will have the same mechanical energy. So mechanical energy at C will also have the same value, which is 5.88 joules. Next, we have got a figure which shows an oscillating pendulum bob the reference level is chosen to be the height of the bob at lowest point, which is C. So C is at the lowest point. It's asking us at which position does the bob possesses only kinetic energy. Now let's just draw a line to show the ground level. So A and B are extreme positions, and at extreme position the bob will come to rest for a moment. That means kinetic energy will be equal to 0, and it is lifted up, so GPE will be maximum. So at extreme, that is at point A and at point E, it will have maximum GPE and the kinetic energy will be 0. But at point C, it's at the mean position, and at the mean position it will move with maximum speed, so its kinetic energy will be maximum, but it is at the lowest point, so that means the height is equal to 0, so that means gravitational potential energy will be equal to 0. So for the answer, we will write at point C, it has only kinetic energy, because at point C, its GPE is equal to 0.